Greetings to everyone. I would like us to look at the concept of directed numbers. Now, when you talk about directed numbers are positive and negative numbers. Positive and negative numbers. And we'll look at how to add and subtract directed numbers. The examples that we have here, example 1, a positive 3 plus positive 5 gives us positive 8. Now there are several methods. When students are given questions that contain negative, at times they are confused. There's negative 4 here plus negative 3. Now, when you have negative 4 plus negative 3, if you are owing 4 pence and you come and take 3 again, you come and borrow 3 pence again, how many are you owing in total? In total, you are owing 7. So it gives us negative 7. Right? This same one again, how do we approach it? Negative 3, in terms of using concrete objects, negative 4, let's say negative 4, you can decide to use red object for negative, black objects for positive. Let's say negative 4 here, negative 4. It means you have 4 negative. 1, 2, 3, 4. Plus negative 3. 1, 2, 3. How many negatives are there? 1, 2, 3, 4, 5, 6, 7. So negative 4 plus negative 3, negative 7. This can be taught concretely. Just like you are owing 100,000 in a bank and you come and take another loan of 50,000. Means all that you are owing is 150,000. And if that has to be expressed, it will be negative 150,000. Okay. Now the third example, let's say negative 5 minus 3. Is, negative 4 plus negative 3, a positive negative here is a negative. Negative 5 minus 3, same thing. If you want to use concrete objects, the red objects for negative, or if you draw negative 5 means negative 5 here. Well, that's negative minus 3, that's plus, means you have negative 3 again. When you count all the negative counters, 1, 2, 3, 4, 5, 6, 7, 8. Negative 5 minus 3 is negative 8. You see, what we are using here, we call them integer counters. Okay, that said, after you do it practically, students are aware of the fact that the negative 5 minus 3 gives another negative 8. Okay, using integer counters or objects or balls as demonstrated, or small diagrams like that. This same one can be done using a number line. Some do use a number line. Let's use a number line and see. Let's use a number line. We have a negative 3. We have negative 3. Zero, negative -1, -2, -3, -4. If we are using the number line instead, let's say for example -1 minus 2 on the number line, right? Negative means you are to the left of the number line. Positive means you are to the right. So -1 minus 2 means I start at -1, I count 2 units backward. 1, 2. We fall on -3. So -1 minus 2 is -3. Okay. Now, having seen that we have when the signs are the same, you must have seen something either using concrete objects or using a number line, using integer counters. You will notice that we can now apply a rule. When both signs are the same, we add and maintain the signs. We add the numbers and maintain the signs. Like -1 minus 2, you see the signs are the same. We just add 1 plus 2 is 3, then the sign is negative. So if you have -100 minus 100, it will just be 100 plus 100 is 200, then the negative sign maintained. Positive 3 plus 5, it gives +8. The signs are the same, you add and maintain the positive. So we are concluding that when two directed numbers have the same sign, you add them and maintain the signs. Okay, let's go to other examples on the undirected numbers where we have two other signs. Let's look at this other example. 4 minus 10. Okay, 4 minus 10. You all see how if you are using a number line, you go to 4, you count how many? 10 to the left. Now, to avoid misconceptions, even here, concrete objects can be used. 4 means +4. Okay, now +4, this is our +4. 1, 2, 3, 4. Minus 10 means plus -10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now when one positive works with one negative, it boils down to 0. This is 0, 0, 0, 0. So how many negatives are we left with? 1, 2, 3, 4, 5, 6. So 4 minus 10 is -6. 4 minus 10 is -6. 4 minus 10 is -6. Okay, we have another situation where we have -2 plus, let's say -2 plus 5. -2 plus 5. -2 plus 5. -2 plus 5. If you are using concrete objects, it means you have negative here, negative, plus 5. 1 positive, 2 positive, 3 positive, 4, 5. Negative here, positive, boils to 0, boils to 0. So how many positives are you left with? 1, 2, 3. So -2 plus 5 gives us +3. So if I'm using the counters, this will be my counters. This one, this negative here can represent, let's say, a red seed. Then this positive, a black one. When you arrange like this using concrete objects, students are using their concrete objects. You will see that whenever they see a unit, one red, one black, it gives 0. One red, one black gives 0. You'll be left now. What we are left now will count. These are how many positives? 3 positives. So negative 2 plus 5 is positive 3. Okay. So which rule can we bring? Which rule do we derive here now? If you are working, when the signs are different, when you have two directed numbers with different signs, what do we do? When the signs of two directed numbers are different, you subtract the smaller number from the larger number and maintain the signs of the larger number. You subtract the smaller number from the larger number and maintain the signs of the sign of the larger number. This is what we mean. Like the negative 2 plus 5. These are two directed numbers with different signs. To do it, neglecting their signs in the first place, I will have 5 minus 2 gives me 3. What is the sign of the larger number? The larger number is positive, so the sign is positive. The answer is positive 3. If it is 4 minus 10, neglecting the signs means 10 minus 4, which gives us 6, right? Which gives us 6. Now, what is the sign of the larger number? The sign is negative. So 4 minus 10 is negative 6. Okay, 4 minus 10 gives us negative 6. So with those rules, we are able to do those operations, adding directed numbers, subtracting, and so on. Now, if you have two numbers adjacent, let's say 2 minus 3. When the negatives are close to each other, like negative becomes positive. So it becomes 2 plus, becomes 2 plus 3, which will give us 5. When the signs are close to each other, negative gives us a positive, close like this to each other. Now, I would like us to look at multiplication of directed numbers. How do we multiply directed numbers? If you are multiplying directed numbers, let's say positive times positive, positive 2 times positive. It means 2 times 3. We all know that multiplication is repeated addition. Positive 2 times positive 3, positive. Now, what if you have positive 2 times negative 3? 2 times negative 3. 2 times negative 3, we are looking at it as multiples. 2 times negative 3. It means we have a group of negative 3, 2 groups of negative 3, if you are to count, right? So we have a group negative 3 plus negative 3, which, as we've seen in addition, gives us negative 6. Okay. Likewise, if you have negative 3 times 2, you have negative 3, you count it 2 times. So what are we saying for the rules for multiplication? A positive times a positive will give us a positive. A positive times a negative will give us a negative. A negative times a positive gives us a negative. And a negative times negative gives us a positive. In other words, we are saying that when multiplying directed numbers, when their signs are the same, we have a positive. When their signs are different, when multiplying, we have a negative. And this same rules works for division. When we are multiplying, when we are dividing directed numbers, when the signs are the same, we have a positive. Like positive divided by positive, positive. Negative divided by negative, we give us a positive. But negative divided by positive will give us negative. A positive number divided by a negative will give us a negative. Okay, that's what we mean by directed numbers here. So if you have negative 4 times negative 5, it gives us positive 20. Positive 20. Talking about the division, the one concerning division. As we say, if you have negative 20 divided by positive 4, negative divided by negative. Look at the sign. Negative, positive is negative. 20 divided by 4 is 5. So we have that negative 20 divided by positive 4 is negative 5. You know, we have many transactions that entails the use of directed numbers every day in our daily activities. Financial transactions in a bank, all the transactions that we do, most of the transactions being done in the bank, you take a loan of, let's say you have you take a loan of 10,000. It means if you had 0 initially in your account, it will be, what will be there will now indicate negative 10,000. I'm bringing it in a real way, in the realistic real life application. We have, if you take a loan, initially you have 0 in your account. We are now looking at more examples. Initially you have 0 in your account, and you take 10,000, means minus 10,000. You see that it will give us negative 10,000. Now, if you have 30,000 francs and you come and put it back in your account, what do you think will be the balance in your account? Your account now is at negative 10,000. If you come now with 50,000, right? The balance in your account, for example, let's say 50,000, it means out of this 50,000 that you have, remove 10 to fill back the debt. It means what will be left in your account will be 40,000 francs. That's the balance that will be left in your account. 40,000 francs will be left. So you see that we are using now the aspect of negative. We are using now the aspect of negative 10,000 plus 50,000. Right? If you are using seats, the signs are different. If you want to use the rule, it will be, since the signs are different, you have 50,000 minus 10,000, which is 40,000, and the sign of the larger number is a positive. That's why we have our positive 40,000. Writing positive 40, writing like that without a positive also indicates that it is positive. Okay, thank you. Thank you for watching. Thank you for subscribing. Have a great time.